Okay, so looking at this integral, what I would look at first is ask myself, is there one term or one monomial in the denominator? And the answer is no. Because if there was, I would split it into two fractions. So then I ask myself, is there a constant in the numerator where I could maybe bring this bottom piece all the way up with a negative exponent? There's not just one term constant. These are techniques, suggestions that I'm giving you based off of the experience of problems throughout the years. So, looking at this, I'm going to go to use substitution of some sort. Okay, so here we go. With parent functions in my brain, what would I assign for you in your experience that you have so far? What should we assign as u? 4 minus x to the fourth. Perfect. So du is what? Anyone? Yep, negative 4x to the third. He's missing though. Dx. Okay, so now I'm going to put this negative 1/4 du is equal to x cubed dx. And you've gotten a lot better now with u substitution to know that anywhere where I saw the x cubed dx, I'm now going to replace it with a negative 1/4 du. Do you agree? Okay, so let's go over here to the rewrite. I'm going to put negative 1/4 out here, constant multiple rule. This is now going to be du, and it's going to be over this u value that we assigned from before. Some of you look at this, and you can see that it's also the same as negative 1/4, that's a 4, 1 over u du. Okay, this is taking the integral of something that will end up with a natural log of an absolute value of some sort. Let me show you why. If I were to rewrite this and attempt to use power rule, I would bring the u up and have the negative exponent of 1. Let's try to reverse power rule right now. What's u to the negative 1? If I do reverse power rule, it would become u to the what? 0. Divided by what? 0. We can't do that, okay? We cannot do that. The rule that we use, when we identify that we would get that error, it's going to simply be, the answer is, I'll write it over here, the natural log of the absolute value of whatever this piece was. You with me? So we're going to put the natural log of the absolute value of u, and what am I missing right now? No, I just integrated. So the du and the summation, they went away. They disappeared. The negative 1/4. That negative 1/4 constant multiple rule that I still have to put out in front right here. Okay? So let's go ahead and write that in. So we have equals negative 1/4. Okay? Now I'm still missing something in my answer. Right now I have negative 1/4 natural log of u plus c. And finally I'm missing one more thing. I need to plug the u back in. I need to plug this u assignment that I had right here so that it's the negative 1/4 natural log of the absolute value of your u, that's a 4, and then plus c here at the end. That would be your answer. Questions?
Can you explain the natural log part?
Yeah,
Like why you use that?
It's just, so so that rule is, when you have something that looks like this, or something that looks like this, something that could look like this. My point is, when you have something in the denominator that's a variable like this, and its power currently holds to be a positive 1, this will end up becoming this natural log. It's the rule of different integration for these kind of problems. Because I can write this as u to the negative 1. I could write this as x to the negative 1. And I could write this as m to the negative 1. And when I integrate, remember, I'm going to add 1 to this power. So it become u to the 0 over 0. And this is undefined. We can't do that. Okay? So the rule of it being is, we're going to, when we get this error, whatever we had down here, it's going to equal the natural log of the absolute value of whatever that was. Like right here. The natural log of the absolute value of whatever that was.
So that's only if the denominator has a variable to the power positive.
Yes.
if
So
for
really good
any
question.
other number,
Any other number, you don't do this. Only if the denominator has a power that is a positive 1. Okay, that's why I highlighted it right here. It's an understood 1. We didn't write it down, but we know it's an understood 1. There's one more thing that's important though. Not only does the power have to be a positive 1, but the coefficient of all of these also has to be what? A positive 1. Okay? That's very important as far as all the integration that we've been doing, all the integration that we will continue in this unit. We're wanting to get these to a positive 1 in that respect. Yeah?
What if there was like a power? What if there was like not a power, a coefficient?
You'd constant multiple rule it out. Yeah. You know what I mean? Okay. Alright, let's do next one.